Alright, so we want to write a polynomial function that has these zeros. So we have 0, 3, and then a 0 of 2 plus 5i. One of the things that we should know is that imaginary roots always occur in conjugate pairs. So if this is a 0 or a root, then this is also. So this is the conjugate of that. So I would, even though this one was not given to me, I can infer it from that one. So anyway, you want to say x minus the root. So x minus 3. And then I want to say x minus 2 plus 5i. So it's x minus the root. So x minus and then 2 minus 5i, like that. So it's x minus the 0 or the root that's given. So that's what I have. So what I want to do is multiply all that together. Now, multiplying conjugates is a whole lot easier. So what I want to do is change this to where it looks like conjugates. So I'm going to distribute the negative. So if I just distribute this little negative sign out here, it looks like this, and then it looks like this here. Now, if I regroup, you'll notice that it looks like conjugates here because I have the same term here and the same term here. The only difference is I have different signs there. The beautiful thing about a conjugate is that you only have to multiply the first and the last terms together. So I'm going to do x minus 2 times x minus 2, which is x minus 2 squared. And then a negative times a positive is a negative. And then I'm going to do 5i times 5i, which is 5i squared. So anyway, if I multiply this out, it's going to look like this. So that's x squared minus 2x plus 4. And then 5i squared is 25i squared because that's 5i times 5i. 5 times 5 is 25, and I times I is I squared. This minus sign is there. And really all I did here was just think of that as being written down twice and multiplying it out using the FOIL method. So anyway, then I have this just by consolidating. Now I squared is negative 1, so since I squared is negative 1, that's negative 1 times negative 25, which becomes 25, which makes this 29 when I add it to the 4. So the only other thing I have to do is multiply this times all of this, and then this times all of this and combine like terms. So this is x cubed minus 4x squared plus 29x minus 3x squared plus 12x. And then 3 times 29, what is that? 87, negative 87, I think. 29 times 3, 27, yeah, 87. And it's a negative times a positive, so it's negative. Anyway, last step is to combine the like terms. So I have x cubed minus 7x squared 41x minus 87. So this is the polynomial that has those zeros. And so the power here was in multiplying this out. If you try to multiply this out without recognizing the conjugates and just multiplying the first terms and the last terms, then this is significantly more difficult. The reason I don't have to do the outer and inner terms is they're going to cancel out. So this is the power of multiplying with conjugates. So pay attention. If you have to search another video on this idea of conjugates, if that wasn't enough explanation for you, definitely search that out because that's what makes this problem much easier. So there, final answer. So you should definitely try this one again until it becomes easy. Bye.